Hey, my name's Mike, a developer from Philadelphia, and in this video, I'm going to be walking you through the handwriting recognition using K-means machine learning project. In this project, we'll take a look at some of these key concepts, including clustering datasets and using matplotlib to visualize clustered pixel data. Without further ado, let's head into it. We'll head over to Codecademy. Here on the Codecademy screen on the left, we have all of our instructions. Here is where we're going to be writing all of our Python. Down here is our terminal output. So this is where all of our print statements and things will be output. And then over here, we have our web browser where all of our graphs will show up. I'm going to move this down just a little bit. And we'll take a look at the handwriting recognition using K-means description. The U.S. Postal Service has been using machine learning and scanning technology since 1999. Because its postal offices have to look at roughly 500 million pieces of mail every day, they've done extensive research and developed very efficient algorithms for reading and understanding addresses. And not only the post office, but also ATMs that can recognize handwritten checks, Evernote can look at handwritten task lists, and Expensify can recognize handwritten receipts. But how do they do it? Right, the U.S. Postal Service sees all of these handwritten addresses and notes. How do they recognize what those are supposed to be, and how can they do it so perfectly? Well, in this project, we'll look at one way that we can do that, which is using a K-means clustering algorithm, which is the algorithm behind all of those technologies. And scikit-learn we can use to cluster images of handwritten digits. So let's get started. We have 18 tasks to complete. And in step number 1, we're going to start by getting started with the digits dataset. So sklearn library comes with a digits dataset for practice. In script.py, we have already added the 3 lines of code, which are these 3. And in addition, we're going to import from sklearn the datasets module. And this is just the dataset of handwritten digits that we're going to be using for this project. So I can say from sklearn import, and this is going to be datasets. And then down here, we'll take the datasets and we'll store the digits from the dataset inside of a variable called digits. So I can say digits is equal to datasets dot load digits. And this is going to give us a dataset of handwritten digits, which is like a bunch of images of digits that we can use. And then down here, we can just print that out. So I'll print out digits, and this should just be a bunch of kind of random information. I don't know how much sense this is going to make. You'll see we have a bunch of these different numbers, and there's all this text up here. So let's start making sense of all this data. We can check off step number 1, and in step number 2, when we're first starting out with the data set, it's always a good idea to go through the data description. So let's print out the data description. So we can say digits.descr, which stands for description, and we're going to look for the size of the images and where the data set is from. So this data set has a collection of images, which are handwritten digits. And these would be digits 0 through 9. And there's just a bunch of these digits that we can throw into our algorithm, and the algorithm will kind of figure out what a handwritten digit looks like. So the algorithm could figure out, okay, this is what a handwritten 1 looks like, or this is what a handwritten 3 looks like. It'll have all that different information. And down here, let's figure out what the size of the image is. So you can see right here, it says attribute information, 8x8 image of integer pixels in the range of 0 to 16. What this means is that we have images of 8x8 pixels. Each pixel has a value of 0 to 16. And 0 would mean that it's a white pixel, and 16 would mean that it's a black pixel. And then anything in between that would be different shades of gray. So this information here, this 8x8 matrix of pixel data, which is just an integer from 0 to 16, essentially represents an image. So then where did the dataset come from? The dataset came from the UCI ML handwritten digits dataset. So that's where all this data came from. And we can check off step number 2. That's done. We took a look at some of this data description, and on to step number 3, and we're going to see what the data looks like. So let's print out digits.data. So this is going to be the actual data that we have. So this would be that pixel data for all of those handwritten images. And you can see that we have a 2-dimensional list, so a list of lists. If you click down here where it says stuck, get a hint, it'll actually give us an idea of how this works. So it says each list contains 64 values, which represent pixel colors of an image 0 to 16. 0 is white and 16 is black. And like I said, everything in between is kind of shades of gray. So each one of these lists right here, like this one and this one, these all represent an actual image, an actual handwritten digit. So we can check off step number 3, and we'll head down to step number 4, where we're going to print out the digits.target. Now the digits.data, this is all the actual raw pixel data for each of these digit images, and digits.target tells us what actual digit each one of these is. So digits.target is just a list of digits. So for example, that first list of pixel data actually is a 0. So it's an image of a handwritten 0. The second one's an image of a handwritten 1, etc. So that's just kind of the answer to all of these data points. Let's check off step number 4. We'll head down to step number 5. And in order to visualize the data images, we need to use matplotlib, which is our kind of visualization library. So let's visualize the image at index 100. All right, so they kind of gave us the code to do this here. I'm going to go ahead and paste this down here. This is all of our matplotlib stuff. So we're just plotting out all this stuff, and then we're showing the plot. So let's save, and this should show us what the 100th digit is. So it looks like it's 4. So this kind of looks like a 4 to me. Obviously, it's very pixelated, but I can kind of make out a rough shape of a 4 there. And this is what it's supposed to look like. So the question is it a 4? We don't know for sure. I think it is. But like I said before, we have all of the answers. So we can just print out digits.target at index position 100. This will tell us what the answer is. In our case, we were right. This is a 4. So we can check off step number 5, and we'll move on to step number 6. And actually, before we move on to step number 6, there is this text here. It says, open the hint to see how you can visualize more than one image. So down here, they have some code which is going to allow us to visualize more than one image. So instead of just having the 4, we could have multiple images. I'm going to paste this in real quick just so we can see what it looks like. So instead of plotting out this stuff, I'll just paste this in. And now we have a bunch of these digits that are showing up over here on the right. So you can kind of recognize some of these, like this is probably a 0, a 1, maybe a 2, a 3, a 4, a 5. So these are all, just handwritten digits that are encoded as images. We can close this hint and we'll move on to step number 6. And we understand what we're working with. So now that we understand how all this data is structured, let's cluster the 1,797 different digit images into groups. So we're going to import the k-means from sklearn.cluster. And actually, we can get rid of all this. So I'm going to remove all of this plotting code right here. We don't really need that anymore. And then up here, we're going to say from sklearn.cluster, and we're going to import k-means. That's step number 6, and we move on to step number 7, which says, what should be the k, or the number of clusters here? Use the k-means method to build a model that finds k clusters. So the question is, when we're using the k-means algorithm, the k-means algorithm is going to take all the data that we give it, and it's going to cluster it into a different number of groups. And it'll do this intelligently. So it'll kind of figure out what pieces of data are similar and what pieces of data should be grouped together. And the only information that we need to give it is how many clusters there should be. And how many clusters is this k value? So the question is, for this digit information, how many clusters should we have in the algorithm? Now, if you think about it, we have 10 digits, right? We have digits 0 through 9. That's 10 different digits. So I think we should probably have 10 different clusters. And if you click on the hint right here, it'll essentially explain that. So it says, because there's 10 digits, 0 through 9, there should be 10 clusters. So k, the number of clusters, is 10. And they have the code here that we can base ours off of. So we're going to call this model, and this is just going to be a new k-means object. And the number of clusters is going to be 10 because we have 10 digits, as we saw. And then we have this random state, which can be 42. And the random state just ensures that every time we run the code, the model is built in the same way. It can really be any number, but they've just chosen 42 at random, and we're going to do the same thing. So close off the hint, and we'll check off step number 7 and move on to step number 8. We're going to use the fit method to fit the digits.data to the model. So down here, we can say model.fit, and we'll pass in digits.data. And this is what's going to go ahead and fit all that data to the model. So it'll essentially form all of those clusters for us. We'll check off step number 8. That's done. And now that we have all this data clustered up, let's visualize all the centroids. Because data samples live in a 64-dimensional space, the centroids have values, so they can be images. So essentially, these clusters that we've created can actually be represented as images. That's what they're saying here. So first, let's add a figure of size 8 by 3 using the figure function, and then add a title using the subtitle function. Now, if you're not super familiar with Matplotlib, you can just click down here and they'll give you all the code that we need for this. So sometimes it's hard to memorize exactly how to do all these things. So there's no shame in looking down here for some inspiration. So we can say plot.figure, and then over here we're going to pass in a fig size, which is going to be equal to 8 by 3. And then we'll say fig.subtitle, and we'll pass in the title. And I'm actually just going to copy this right here because this is exactly what we're going to want to put in. So they have the title, and then they also have some styling information like the font size and the font weight. So we can close off that. We'll check off step number 9, and let's move on to step number 10. It says scikit learn, sometimes called centroids, cluster centers. Write a for loop to display each of the cluster centers like so. So here's all the code that we can use to display all the cluster centers. And the cluster center should be a list of 64 values, 0 to 16. And here we're making each of the cluster centers into an 8 by 8 2D array. Let's copy this code. And what this is going to do is it's basically just going to plot out, just like we have over here, all of the different clusters. And then we should be able to visualize them. So we'll actually be able to see what all the clusters look like. Outside, so that's step number 10. We'll check that off. And then step number 11 says, outside the for loop, use .show to display the visualization. Down here, we'll just say plot.show. And now we should be able to see all of the clusters. So I'm going to save. And here we have the 10 different clusters that got formed. Now, these aren't necessarily in numerical order, and the algorithm didn't put them in numerical order because it didn't really know that it was supposed to. But you can see like this first one here is probably a 0. Then we have a 9. This looks like a 2, maybe a 4, a 6. This could be either a 1 or an 8. So some of these look kind of similar, and if we scroll down here, they actually tell us what all the answers are. So index 0 is a 0, index 1 is a 9, etc. But you'll also notice how the centroids that look like 1 and 8 look very similar. So here is 8 down here, and here's 1. These look pretty similar. And then also 1 and 4 look similar. So 4 is down here, and 1 is up here, and those look pretty similar as well. It's kind of easy to mistake those. However, the algorithm was able to cluster together essentially the different digits, right? We have digits 1 or 0 through 9 here, and they're pretty recognizable. So we can check off step number 11, and we'll move down to step number 12. And step number 12 is optional. And if you want to see another example that visualizes the data clusters and their centers using k-means, you can check out the example on sklearn. So sklearn actually has their own example of this. This is an off-platform piece of code, so it's not code that we can write inside of here. So I'm going to leave that up to you guys to do on your own. But I would recommend doing it. The more you can work with different data sets and the more you can visualize these things, the better off you're going to be. So I'll check off step number 12 for now, and I'll leave that up to you guys. And in step number 13, we're going to be testing the model. So instead of feeding new arrays into the model, let's do something cooler. Inside the right panel, go to test.html. So we've passed all this data into our k-means algorithm. The k-means algorithm spit out these different clusters, which represent essentially the different digits. Now we can go to this test.html page and we can test this out. So the way that this works over here, and we can check off step number 13 and we'll head down to step number 14. The way this works is you can draw different digits inside of each one of these boxes, and then we can throw those digits into our k-means algorithm and see if it's able to actually tell what number we were drawing out. The question says, what year will robots take over the world? Use your mouse to write a digit in each of the boxes. So I think maybe robots might take over the world in like 2039. So why don't we try that? I'm going to write out 20. So here we'll have a 0, and then a 3, and then we'll have a 9. And as you guys can tell, my handwriting on the computer is really bad. But if we click this get array, we'll get an array or a two-dimensional array that has all of that encoded data. So this is all of the data that represents these characters that we just drew. So now we can throw this data into our k-means algorithm and see how it does. So I'm going to check off step number 14. And in step number 15, we can create a new variable named new samples. Down here, we'll do that. And if you guys want, you can get rid of all of this plotting data. We don't necessarily need that anymore. Make sure that you don't get rid of any of the model stuff though. So down here, we'll create a variable named new samples, and we'll set this equal to numpy.array. And then in here, pass in all this information that we generated. That's step number 15. We'll check that off. And then on to step number 16, we'll use the predict function to predict new labels for these 4 new digits. And we're going to store the predictions in a variable named new labels. So let's create that variable, new labels, and that's going to be equal to model.predict. And then inside of here, we're going to pass in those samples. So it's just new samples. So that's step number 16. We can check that off. And in step number 17, it's saying, but wait, because this is a clustering algorithm, we don't know which label is which. Now, if you remember when we saw all of those clusters over here, they weren't in numerical order. So it wasn't like 0, 1, 2, 3, 4, 5, etc. It was like 0, then a 9, then a 3 or a 2. They weren't, sequentially in numerical order. And so what we're doing down here with this for loop is we're basically mapping them all to the correct digit. And that way we'll be able to tell if we got the digits right or not from our algorithm. So just paste that code down here below. And when we save, down here we should print out what the algorithm thought these digits were. So we had 2039, and when I click save, let's see what we get. So instead of 2039, the algorithm thought this was 7072. That's interesting. Why don't we try one more? So that one wasn't super successful, but let's try another one. Let's try 0, 3, 9, and maybe a 2. And let's see how the algorithm does on that. So we'll get the array again. I'm going to paste this in here. So up here, we'll replace this whole chunk of data with the new array. And now when we save, let's see if it gets 0392. 0393. We were so close, but the point is we got 3 out of 4 digits correctly. So in the span of just a few minutes of writing this algorithm and training it on the data that we had, you can see that we were able to get an algorithm that could almost perfectly predict what numbers we passed into it. And the question down here, which is number 18, says, is the model recognizing your handwriting? Remember, this model is trained on handwritten digits of 30 Turkish people from the 1990s. Try writing your digits similar to these cluster centers. So I'll leave it up to you guys to play around. This is kind of a fun little interface where you can draw your digits as close as possible to these digits and you can see how they work. So the question is, our algorithm is only so good. How do algorithms like the UPS algorithm or ATM algorithms, how can they get so good at training handwriting data? And the answer really is that they just have more data to cluster together. So we only had, less than 2,000 of these handwritten digits that we passed in here. But if you're someone like UPS, you might have 1 million or multiple million examples of handwritten letters and characters and digits that you can train your algorithm on. So that's how they can get so good, is because their algorithms have just been trained so well in fact that they're almost better than an actual human being who's trying to read the address in most cases. So that's how we can take an algorithm like this and ramp it up. We just need more data to train it on. But as far as this project is concerned, that is the last step, so we can check that off. And just to reiterate some of the main themes that we looked at, we took these images and we passed in their pixel data into our algorithm. And that's a very common thing to do. Generally, when you have images, think of things like facial recognition, or in this case, handwriting. You're passing the images in as pixel data, and then the algorithm uses that pixel data to figure out what the image looks like. And then we took that data and we passed it into our k-means algorithm, and the k-means algorithm separated all of the images that we passed in into 10 different clusters. Those clusters ended up representing the 10 different digits that we see 0 through 9. And then finally, we were able to test the algorithm ourselves using this little interface over here. So like I said, keep playing around if you want. Try to match your digits as closely as possible to the digits that got clustered together. And from all of us here at Code Academy, I just want to say thank you so much for watching. I've been Mike, and happy coding.